Hello everyone, Victor is here, your organic chemistry tutor, and in this video I want to go through a synthesis where we are going to start with benzene and butane as our only sources of carbon in the molecule, and we are going to be looking at the synthesis of this complex ketone on the right. And like with any synthesis, there can of course be multiple different ways how we can accomplish it. So I'm going to show you one, and you let me in the comments below if you can think of any other ways how to do that. And so jumping into my retrosynthetic analysis right away, the first thing that I'm seeing here is that I will have to create this bond between my benzene and 4-carbon chain. And when it comes to a carbon-carbon bond formation, especially in aromatic chemistry, there are going to be two main reactions that we are going to be looking at. One is going to be our good old friend Grignard reaction, and two is potentially some sort of a Friedel-Crafts reaction. Since in this case, neither Friedel-Crafts alkylation nor Friedel-Crafts acylation seems a particularly good choice, I'm going to look into the Grignard reaction. Because one other thing that I'm noticing here, that if I look carefully at my molecule and number the place of attachment as carbon number 1, at the second position over here I have a functional group. And whenever we're making a new bond and we have a functional group at the second position via the Grignard reaction, that is a dead giveaway of a Grignard plus an epoxide, which also supports my idea of using the Grignard reaction for this one. I also see that the functional group that I have over here, that is a ketone, so I'm going to first focus on my retrosynthetic analysis on how we're going to synthesize that ketone, and probably the most straightforward way of making a ketone is going to be via the oxidation reaction, which means that my predecessor in this case is going to be an alcohol. And of course, when it comes to the oxidation reaction itself, we have about a million of different ways how we can accomplish that, so let's say we're going to use the Swern oxidation, which is a two-step process where we are going to first react our alcohol with the oxalyl chloride in the presence of DMSO, and then we're going to cause the final oxidation by treating everything with a base, triethylamine or pyridine are the usual choices. Now, going back to my retrosynthetic analysis here, I know that I need to make this bond over here, and we have already agreed that we need to make that via the Grignard reaction, which means that my predecessors are going to be the corresponding phenyl magnesium bromide and the epoxide. In this case, the Grignard can easily attack our epoxide, open it, and after the corresponding acidic workup, we are going to get our alcohol. Now, of course, bearing in mind that our starting materials have to be benzene and butane, we have to make this Grignard reagent and the epoxide. The epoxide can be made via the epoxidation of the corresponding alkene, which we are going to make from the corresponding alkyl halide, which we can make via the radical halogenation from butane, our starting material. And when it comes to our Grignard reagent, our phenyl magnesium bromide, that one we can make like we would make any other Grignard reagent by treating the corresponding bromide. In this case, that's going to be just bromobenzene, which we can get from our starting material, benzene, by doing a simple halogenation reaction, simple electrophilic aromatic substitution. So this is a fine example of what we refer to as a convergent synthesis, where we start with one starting material, we modify it all the way to the corresponding important reactive intermediate. Then we take our other starting material and we do a sequence of steps until we get another intermediate, and then we combine both of those intermediates and maybe do a couple more steps, in this case Swern oxidation, which we can potentially substitute with a single step process like maybe oxidation with PCC or something of that sort to get our final product. And the important take-home message here is that whenever you have a synthesis that you need to make, and especially when you have multiple different starting materials, do not try to accomplish the synthesis in a linear fashion. Most likely you're going to start with one starting material, make some sort of intermediate, then take another starting material, make some sort of intermediate from that one, and then combine them somewhere later on in your scheme. Convergent synthesis is a very common synthetic strategy, so by now in your course that is probably a very good idea for you to start looking more into that and applying that to your synthetic problems. And that's all I have for today. Thank you for watching, and if you learned something new today, hit the like button and let me know about that in the comments below. Subscribe to the channel for more awesome organic chemistry stuff. Watch this video next, and I will see you next time.